Okay, after random we've got TexMap color. TexMap color has, you can see all those inputs and outputs there. We'll get rid of those too. TexMap color is going to take a bitmap input, and in this case we're going to go ahead and just set up a basic bitmap that we keep on hand. Not Claudia Schiffer, but let's go UV ref map. And what we can do is we can drop this actual map slot as an instance into the TexMap color and turn on preview, and we can see what that preview looks like. And what will happen with TexMap color is, let's say we're getting information about a collision detection. We're using a U deflector somewhere. If we detect on a node in a particle, hey, there was a collision at this UVW location. Let's feed that out into the TexMap color. TexMap color looks at the UVW, looks it up on the map, outputs what is the color at that position, or what is the alpha value. So this is great for doing lookups. It's especially useful if you use intersect. You can find information without actually having a particle collide with anything. Okay, back to helpers, TexMap color. Now we get into the time series. These are fun. TimeBase is a way for thinking particles to have each particle calculate things in its own time space. TimeBase, time space. This is right now it's set to global, so it's going to treat it all the way over time. We've got dyne sets. If you animate the dyne set on and off, then you can actually have this time correlate to that timing, as well as active, whether or not this in is being specified. And then you can do things like you can feed a particle into this particle input and set, maybe I want him to be 40% with an 80% variation. So any of those green particles will be traveling at pretty slow time with a bunch of variation, and output their new time. What is now each green particle kind of has his own time space that he's dealing with. This is especially useful in animation, geoinstance. Okay, we've got TimeLoop. TimeLoop is going to just take a time input, and it's going to loop that time over and over, or ping-pong it up and down. And this is a good way to have it just continuously looping. We've got timer. Timer is very useful. Timer, we just took a look a second ago at what we could do, but we could do things like when a particle age is born, then we can start a timer that says, okay, for the next 30 frames, I want this particle to, let's see here, let's make it, I want that particle to add some velocity with a little variation, a little direction variation. And we'll expose the on for the velocity, and so that it's bound to this time, and it will turn off when he's done counting. So what happens here is this green particle, when he's born, he is kind of starting his own little timer space. It's a little, just kind of a logistical thread that's going to go ahead and start. And so for the next 30 frames, he is going to be counting on his own up to 30. And then he can output whether or not he is counting. He can output his actual current time value, which will be in a, ticks and delta ticks. And then there's the actual particle output. So in this we'll say, okay, I am the green, I've entered this time space. My time space, this is how I reference me. If I want to do something to me, I'm going to use this particle output. Okay, and we've got Timer1. Timer1's kind of the same, except that it does a little bit different. It has an interesting time playback function. We took a look at this in one of the other sample videos, but I'll just give a brief overview. What's going to happen is, say that all particle again, coming in there, and actually we can also pipe the particle straight into the start. So as soon as that particle comes into existence, it's going to go ahead and start his timer. Anyway, so this Timer1 is going to say, okay, I'm going to count from 0 to 30 in 30 frames. Well, that's not very exciting. Let's make it interesting. I'm going to count from 0 to 300 in 30 frames. So he's going to output kind of compressed time. He's going to go through something really fast for that first section. And then I'm going to count from 300. Let's make this 200. Then his time output value is going to go from 300 to 200. So it's going to decrease over, and that decrease is going to play back in 50 frames. So at first he's counting from 0 to 330 frames. So from 0 to 30, his time output is already gone from 0 to 300. And now from 30 to, let's see, well, add 80 there. I'm sorry, add 50 to 30 so we get 80. And so, yeah, just so we don't lose anybody. We play 0 to 300 in 30 frames. Then we play from 300 to 200 over the next 50 frames, which get to 80. And then we're going to play output a time of 200 to 0 over the next 30 frames. So 30 off of 80 is 110. And then of course we can extend that if it continues to be true, or we can force it to only happen once with a single. Same kind of thing, he's going to output, is my time running, what's my current time value, and who am I, which particle is keeping track of this time.